In this video, we're going to discuss condensing logarithms. Condensing works pretty much backwards of expanding logarithms, so if you're comfortable with that, then today shouldn't be too terribly crazy. So for condensing logarithms or expanding, we use three main properties. We use the product property, quotient, and the power properties. We're going to discuss once again how those kind of work. I'll prove number 3 at the end, and hopefully we're good to go. So we talked about this in a previous video, but essentially if you have a product on the inside of a log, it is the sum of the logs that goes along with those exponential rules. If it's a quotient on the inside, it would be the difference. And then if we have a log being raised to a power, if that argument on the inside is being raised to a power, it gets to move to the front as the coefficient. So we just slide that in the front. Normally for expanding, we go in this direction right here. So we start out with something pretty tight, one logarithm with a pretty complicated argument or thing on the inside. And then we want to try to make them pretty simple logs if we can. We might have more than one. We probably will have more than one, but it'll be a simpler log in itself. Condensing, we just work backwards. We're just going to go in this direction right here when we condense. So we're going to take multiple logs and try to put them back together or mash them back together into one logarithm. Both have their benefits. Usually condensing is nice for solving logarithmic equations, which we'll get to later in this section. I will prove number 3 at the end, and then we do have a couple of these properties or these number values that we've talked about before. Log base b of 1. Anytime the base is whatever of 1, it's always 0 because b to the 0 would equal 1. If the base matches the argument, if those are the same number right there, if they're both 5s, it'll always equal 1. And then if the base matches the argument and it's being raised to a power, then that exponent is just the answer. So we're going to take a look at some example problems of condensing these logarithms, and hopefully we'll be good. So for condensing logarithms, we kind of go backwards. In expanding, I usually use either property number 1 or number 2 first. I see how many terms are in there, and I split them up into their own individual logarithms. Okay, and then if they have power still, then I use property number 3 and I move it to the front. So when I condense a logarithm, I kind of do the same idea, except for I'm actually going to do property number 3 first. So if it has a coefficient, I'm going to move it up to the exponent. So these both have coefficients. I've got a 2 in the front of this one and a 3 in front of this one. So both of those can move to their exponents on the inside. So I would first start out with writing this as log base 3 of x squared, and then plus log base 3 of y cubed. So those coefficients become the exponents of the argument or whatever is on the inside of that logarithm. Now I've done the number 3 or the third property. Now I look to number 1 or number 2. Am I adding or am I subtracting those logs? This one I am adding those logs together, and so since when I add logs, I multiply the inside to make it the product on the inside. So basically you're going to mash these logs together as log base 3 of x squared y to the third. So the sum of those logs becomes the product, or that little dot right there on that logarithm. Okay? So that's kind of the idea behind condensing. It's a little bit more complicated on the inside here, but it is just one logarithm for both those. So that might have a benefit down the road when we start solving some of those equations. Next example, this one has a difference. Difference means I'll use that second property, the quotient property for this one. But I always like to move my coefficients up to the exponents first. So I am going to take the 5 and the 4, that's this number and this number, and move them up into the exponent. So I would first write log base 100 of x to the 5th, and then minus log base 100 of y to the 4th. So I use that third property, the power property, first on this one. Now I notice that there's a subtract. I'm taking the difference of these two logarithms. So that means when I mash these together, when I condense these, they'll be in one logarithm. I'm leaving the base alone. And then I'm going to divide or make a quotient on the inside. So it will be x to the 5th and then all over y to the 4th. So that would be the condensed version of that log. Same value for both. If you like it in the condensed version or the expanded version, it just kind of depends on the problem that you're working on. All right, so a couple of more tricky examples to take a look at. Sometimes we like to write these logs kind of in weird, fancy ways. I do see a 2/3 in the front right here, so I'm already thinking that first property, moving that to the exponent, even though it's a weird 2/3, not an integer, but I can still move that to that exponent. And then I do have this weird like over 2. So this is the first thing I want to fix. I want to make that a coefficient if I can. Fortunately, over 2 is just the same as having a 1/2 in the front. So I would actually just move that 1/2 into the front and make it log base 9 of x, and then plus 2/3 log base 9 of y. So now I can see I just have a 1/2, or I'm taking whatever this log was and I'm going to multiply it by a half, or I'm going to chop it in half, right? That'd be the same as what this over 2 is doing right here. So if I put the 1/2 in the front, it's a little easier to see I'm using that third property first. So the 1/2 goes to the exponent, the 2/3 goes to the exponent, and this would give me log base 9 of x to the 1/2 power plus log base 9 of y to the 2/3 power. So that's looking pretty good. I've got my coefficients moved up to the exponents. Now I can condense, I can put these logarithms together. If I add logarithms together, I make it a product on the inside. So it would be the log base 9 of x to the 1/2 multiplied by y to the 2/3. Now, x to the 1/2, you can leave it like that, or you might see it written as the square root of x, because x to the 1/2 and the square root, those are the same thing. And then the product of y to the 2/3. If I make that rational exponent an exponent, this would be the third root. Oh, something went weird there. Third root of y squared. So y to the 2/3 power is the same as the third root of y squared. All of this is on the inside of that logarithm, and because I made this an addition sign right here, it is a product right there on those two. So that's the condensed version of that problem at the beginning there. Next example. This one's a little tricky. It kind of catches some people for a loop a little bit, but I do see I've got some coefficients. I've got a 3 in the front here, a 2 in the front there, a 1/5. So I can move all of those to the exponent. So I always like to do that one first when I'm condensing. So I'm going to write this as, not as that, I'm going to write this as log base 4 of x to the third, and then minus log base 4. Now that x plus 1 is all going to get squared. So I'm going to leave that parenthesis set there. X plus 1 is all going to be squared. And then I do have that 1/5 power. So this would be plus log base 4 of y to the 1/5 power, like so. All right, so that's looking pretty good. Now I can condense this. I do have 3 terms. If you want to do this in one step, you can. Kind of the shortcut for this for me is I look to see if it has a plus or minus sign in the front. That tells me if it's going to be on the numerator or the denominator. This technically will have a positive sign in front of it. There's no sign there, so this is a positive log. A negative sign, which means this is going to be in the bottom of my quotient. And then I have a plus sign. That means it'll be in the numerator. It'll be on the top of it. It has a positive exponent, so it should stay put. Technically, this negative can also move with it. It gets a little dicey there, so you got to be a little bit careful. But a -2 there would actually move to the bottom using exponent rules. But we'll maybe save that for another time. Okay, so I'm going to condense these all in one step if I can. I'm going to write this. I did that again. Log base 4, and then the x to the third is going to be on the top of my quotient. The y to the 1/5 power, which I'll write that as the 5th root of y, will be also on the top. It has a positive coefficient and a positive coefficient, even though it's not there. And then this one has the negative, which tells me the x plus 1 will go in the denominator. So I would write this as x plus 1 squared, like so. So that's the fully condensed version of that one. Pretty gnarly on the inside for this one. We've got a lot of stuff going on. So sometimes the condensed version is a little cleaner. If we're solving, sometimes the expanded version will be a little bit cleaner. So it just depends on what you're doing with it. Real quick, we're going to talk about the proof of rule number 3. Why does that power just get to magically move in the front? The first and second property makes sense with those logarithmic rules, but this third one is just a little bit weird. So I just want to kind of show you how I think about it and how I wrap my brain around it. This y right here, this y is the power or the exponent on this x. This is essentially counting how many of those x's are in there. So I'm going to use that idea and try to expand that. If I were to expand this log, it would be log base b of x multiplied by x multiplied by x multiplied by x multiplied by, well, I got lots of x's on there. In fact, I think I've got y x's on the inside. However many that is, it might be 10, it might be 5. Who knows exactly how many that would be. Well, this really is a bunch of quotient rules. We've got a quotient property. So we've got all these quotients, or my goodness, I said it wrong, products. We have all of these products on the inside of this, which means I could expand this property. I could expand that y times. So it would look something like this. It'd be log base b of x plus log base b of x plus, you probably see where I'm headed here, plus, let's go dot, 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 plus log base b of x. And I'm going to say, I'm going to have y of those. So I have the same number of x's I have up in the top part here would be how many logs I would expand. So in my mind, if I'm adding, let's say this log here and this log here, well, that's one log plus another log, that's 2 logs. Well, if I combine a third one in there, that's 3 logs. And if I'm adding numbers together, I just put that number as the coefficient in the front, which tells me that there are going to be y log base b of x's. So this y is counting how many of these logs I'm adding together, and this y is counting how many x's I'm multiplying together. So those two are very connected, and that's why this property works out so nicely that we can just move that number to the front. All right, hope that makes sense. If you got any questions, feel free to email your teachers, and we'll try to help you out as best we can.